Kepler's third law tells us that the square of a planet's orbital period is proportional to the cube of its average distance from the sun. Let's first look at the words orbital period. Orbital period is the time a planet takes to orbit its star one time. So let's say we take a look at the planet Earth, and there is the sun, and so the planet Earth is going to orbit one time around the sun in a time equal to 1 year. So then the orbital period is equal to 1 year. And we give the letter P for orbital period. And in this case for the Earth, it is 1 year. So now let's go look at average distance. So we take a look at the distance that the planet is from the sun as it orbits, and then we find the average distance. And so that average distance is going to be given the letter A. So P is the planet's orbital period, and A is the average distance from its star. And thus, Kepler's third law says the square of the planet's orbital period, or P squared, is equal to, or proportional to, so I'll draw a little fish symbol for proportional to, the average distance from the sun, and that says the cube, so that would be a 3. Now, in its original form, Kepler said P squared is equal to A cubed, and so that's how we're going to leave it. P squared is equal to A cubed is Kepler's third law. Now we can make this easier to look at. P squared is just P times P, and then A cubed is just A times A times A, 3 A's. Now P has to be expressed in the units of years, and A has to be expressed in the units of astronomical units. You cannot use any other units in this equation.